pop quiz. The pop quiz, which was related to the fluid. Scientists use weather balloons to carry equipment into the upper atmosphere and to monitor the weather condition. The photograph shows a weather balloon as the equipment is there. Upthrust act on the balloon. The balloon is released and it accelerates upward. State what is meant by the upthrust. So definition of the upthrust, actually upthrust is a force which the fluid applied, like upthrust force is the upward force which the fluid applied, or that is also equivalent to weight of the fluid which it displaces by an object. So upthrust is the upward force applied by the fluid due to displacement of fluid by object. So how much the fluid displaced by the object, the weight of a fluid, that is also refers to the upthrust. When a balloon is released, the initial upward acceleration is 4.8. Show that the weight of a balloon and the equipment is 13 newtons. The volume of the balloon and the equipment is 1.63 and the density of the surrounding air is 1.23. So when the balloon is accelerating upward, so means upthrust is more than the weight. That's why it is accelerating upward. So we can say that, and there will be a drag force. The drag force will be there, but that because no value or nothing, no information about the drag is given here. So what we'll do, we'll ignore the drag. Drag force will oppose the motion. So here we are ignoring the drag as nothing, no information about drag. So we can say the upthrust minus the weight is equals to ma because F is equals to ma. So force is mass multiplied by acceleration, where F is a resultant force. So upthrust minus weight is equals to, we want to work out the weight. So the upthrust minus ma is equals to weight. How to work out the upthrust? We know the upthrust is equals to density. Upthrust force is equals to density of a fluid, volume of object, and gravity. So density of fluid, volume of object, gravity minus ma is equals to W. So density of the fluid, that is the air, 1.23 kilogram per meter cube. The volume of the balloon and the equipment, that is volume of object, 1.63. The gravity will take as 9.81 minus then here we have to substitute the mass, but we don't have the mass. We can substitute the mass. How we can substitute the mass? Because we have acceleration is given. The acceleration is 4.8. So first, what we can do, we can work out the mass by substitution and then multiplied by gravity, because like this is ma and this is mg, which we need a weight. Otherwise, if we keep the mass and the weight, then we'll have two unknown, like weight will be unknown and the mass is also unknown. We cannot solve this equation. So what we can do, we can convert this weight into mg and then work out the mass. So here, in place of W, we can replace by mg. And acceleration is given. The acceleration of the equipment means the balloon is given, which is 4.8. So this will be m into 4.8, and this will be m into 9.8 or 9.81. This will move other side. So we'll have 1.23 times 1.63 times 9.8 equals to 4.8 m plus 9.8 m. So when we simplify, like first we'll add 4.8 plus 9.8. So it will be 4.8 plus 9.8, 14.6. So this will be 14.6 m, and this 1.23 times 1.63 times 9.8, and then this whole will go there in division. So 1.23 into 1.63 into 9.8 divided by 14.6. This will give us the m. 14.3. But the acceleration is given 4.8. So this is m into 4.8, and then the gravity is 9.8. So when we divide them, we'll get the mass. And from the mass, we can work out the weight. Weight is mass into gravity. So we'll get the weight as well. So m will be 1.34. So 1.346 kg, that will be m. And then multiplied by gravity, you will get the weight of this equipment and the balloon. The graph shows how the density of air decreases with the height above the ground. So this is a variation of a density. Scientists want to make measurement at the height of 25 kilometer where balloon would stop rising. The balloon will expand as it rises and will burst in if the volume exceeded 50 meter cube. Deduce whether the balloon could deduce whether the weather balloon could support the equipment at a height of 20 kilometer without bursting. So the density of air changes as the height or altitude change. Like it is much denser at the ground level, but as we rise, the density it gets thinner, so density decreases. So first, what we can do, we can work out. We already have the upthrust force. Like the density of the air, volume of the weight is 13 Newton. And at 25 kilometers, the balloon will stop rising. So when it will stop rising, like initially, why it was rising? Because the upthrust was greater than the weight. Upthrust was more than the weight, so it was accelerating upward. Then eventually what will happen, it reach a height where the upthrust will, and the upthrust will start to decrease. Why the upthrust is decreasing? Because upthrust is density of fluid, volume of object, and gravity. Density of a fluid is decreasing and volume of object will increase because as a balloon is expanding, the outside pressure is less. But overall, the product is decreasing. That's why the upthrust will decrease. So once it reaches a height and it will stop rising, it means the upthrust and the weight will be equal. So weight will be equals to upthrust. And we already calculated the weight in the previous part, like 13 Newton we have to show. So we can say the upthrust should be equals to 13 Newton or 13.2 Newton as the balloon is not rising. Now using this upthrust, we have the formula. Upthrust is density of a fluid, volume of object, and gravity. So if the upthrust is 13.2 and at 25 kilometer, altitude of a 25 kilometer, what is the density? You will draw a line. So 10 boxes equals to 2, so each is 0.02. So 0.04, each is 0.02. So it will be 0.04. The density will be there, so 0.04. The volume of the balloon object we don't know, and the gravity is 9.81. So this whole factor is multiplied, other side divided. So 13.2 divided by 0.04 times 9.81. This will give us the volume of object. So the volume of object with this one, 33.6 if you divide, okay. So 33.6 if your volume is, if this with these results, 33.6 meter cube. So the balloon will expand as it rises and burst if it exceeds 50. So we get at this height the volume of the balloon is about 33. So which is less than 50. So the balloon will not burst. Is it clear? This one? The next is weather balloon made of a strong material will rise and eventually stop expanding, and it will continue to rise until reach a maximum height. Explain how and why the velocity of the weather balloon changes when it releases until it reaches a maximum height. Ignore any effect of the viscous drag or a drag force. And it's a 6-mark question. Static is there means like your answer should make a sense, like, and you should relate the points with each other. You cannot just directly write one point, then another point does not relate. The points should relate with each other. So first thing, what is in the beginning, what is happening when we release the balloon? Balloon is rising up, so weight is more, upthrust is more than the weight. So if the upthrust is more than the weight, so it means there will be a resultant force upward. If there is a resultant force upward, this resultant force will cause acceleration. As it causes an acceleration, what will happen? The velocity will change. But it is rising to a certain height, the upthrust is decreasing. Why the upthrust is decreasing? Because the density of the surrounding air is decreasing. Because upthrust is density into volume into gravity. The density is decreasing. That's why the upthrust is also decreasing. So when the upthrust decrease, weight is constant. So the resultant force start to decrease. So acceleration will decrease. And eventually what will happen? The weight is greater than the upward force because the upthrust is decreasing. So weight is greater than the upward force. So it will decelerate. And when it will decelerate, like it will slow down if the weight is more than the upthrust, and eventually it will stop. So 3 phases you have to explain, each phase 2 marks. First thing, first point, the upthrust is greater than more than the weight. So if upthrust is more than the weight, what will happen if upthrust is more than the weight? It will result greater, like resultant force is upward. It will accelerate upwards. Then the second point, the upthrust decrease as it rises. When the balloon will rise, because the density of a surrounding air decrease. The resulting force decreases. Which reduce the acceleration. And the last point, when upthrust is less than weight, it will decelerate because the resulting force is downward, opposite to direction of motion. So there is a resultant force downward, and then eventually it will stop. So that's why it's of 6 mark. Like each part, the first part is acceleration part, second part is acceleration decreasing part, and the last part where it stopped acceleration is 0. Is it clear, this one? The structure of the answer? The next question, student carried out an experiment using a data logger to record the motion of a ball bearing as it falls through a liquid. State the condition under the Stokes law apply when the object is moving through a fluid. So first thing, Stokes law is applicable when the object is like the fluid flow around the object is laminar. And the object must be small and spherical object because uh, according to Stokes law, the viscous drag or a drag force is 6 pi eta r and v. So this drag force, it's it's only applicable for a spherical object, one thing, and then very small spherical object. So first condition, object should be spherical and small. And the second thing, that the fluid flow around the object should be laminar. If it is a turbulent flow, then we cannot apply this. The graph obtained by the student is shown in below. Explain the shape of the graph. So you can see this is a displacement graph. What for a displacement graph, what the slope represent? The slope represent the acceleration. Sorry, slope represent the velocity, not the acceleration. So what happened to the slope? So slope refers to inclination with x-axis. So if we draw the horizontal line, you can see the angle is increasing and then the angle is constant. These parts until it, so the ball bearing, I say this is a fluid, we drop a ball bearing. So in the beginning, like ball bearing is in our hand and this is a displacement, like it is say 20 centimeter above, or the height of the fluid in the container is 20 centimeter, the depth you can also say. So when we release this, in the beginning it's in our hand, so initially it is at rest, stationary. When we release, what will happen? The velocity, in the beginning the velocity is increasing because the slope increase, and then the velocity is constant. When the velocity is constant, it means the weight which is acting downward, the upward force, the upthrust acting upward, and the drag force, which is also opposing the motion, they are all balanced. So if you have a displacement time graph, the first thing what you will mention for a displacement time graph, the slope represent the velocity. So in the beginning, the velocity is 0 or it is stationary. Then what happened? As we release, the velocity start to increase because the gradient is increasing, and then it reaches a constant velocity as the gradient is constant. So the displacement time graph, the slope represent velocity. Don't say speed because it's a displacement time graph. If it was a distance time graph, we'll say speed. So slope represent velocity. So what will happen? Initially, the slope is 0. So it is at rest. When release, the slope increases, which shows velocity is increasing. And when they say something like use a graph, you can also code the value. The best answer, best way, like we should code the value. So we can code the values, like example, in the beginning or first 0.04 second or 0.2 second, it is at rest. And then from 0.4 second to example, till this point, we have a straight line. So till this point, we have a straight line. So we can say from 0.04 seconds to about 0.38 seconds or 0.36 second, it's or 0.34 seconds. So 0.34 second, and here this is like two boxes are there, so 0.04 second. So in this part, it is the speed is increasing or it is accelerating, and from 0.34 second until it hits the bottom of the container, the acceleration is zero, and it is moving at a constant speed. So whenever graph is given, try to use the values, the codes, the number from the graph. The ball bearing had a diameter of 1.6 millimeter. The difference between the upthrust and the weight is this. Calculate the viscosity and assume that the Stokes law is applicable. And we already have the graph. So from the graph, we can work out the terminal velocity. The formula which relate the terminal velocity and viscosity. The terminal velocity is 2 by 9 eta is in the denominator. Difference in the density of fluid, density of object, g r square. This is a direct formula. Or because it is moving at a terminal velocity, so weight is acting downward, upthrust is acting upward, the viscous drag is also acting upward as it is going down. So we can say the upthrust plus the viscous drag is equals to weight, or upthrust minus weight is equals to viscous drag. The difference is given, the difference between the upthrust and the weight. So this value is given to us. So this is 1.46, 1.45 into 10 power minus 4. The viscous drag is 6 pi eta r and v. R is a diameter, R is a radius, so diameter is given. So the radius will be half of a diameter, means 0.8 millimeter. But this is in millimeter, we have to convert into meter. So divide by 1000, or we can say 0.8 into 10 power minus 3 meter. So we get the radius. So we have the radius. What about the terminal velocity? Pi is constant, 6 is there. What about the terminal velocity? Because it's related to the first part. So you will work for a displacement graph. So for you can take a gradient of this part for a straight line, because that is a part it is moving at a constant velocity. So take the gradient of this part using a formula y2 minus y1, or you can also use like change in the velocity. If I take from here, the first point on x-axis is x1. The first point on y-axis is y1. The second point, we can take this as our second point, so both will be 0. So we can use a formula y2 minus y1 over x2 minus x1. We'll get a negative answer here. The negative gradient will be there, because it is the displacement opposite to the direction of displacement which we measure. That's why we get a negative answer. So this will be 0 minus 10 divided by the time interval you can take. So this will give you the, here 10 boxes equals to 0.2. So each is 0.0, 6.0, 0.6248, 66 and 68. So 0.68 this, and this is 1.1, 1 point, like this will be 1.02, 1.1, 1.12, 1.14, 1.16. So 1.16. So we just use the formula 1.16 minus 0.68. This will give us the velocity. But that will be in centimeter per second. So don't forget to convert into meter per second. So we'll divide it by 100. So we'll get in meter per second. Because displacement is given in centimeter. Unit conversion is always important. Use the SI units. Can we just take the value like 12 centimeter? yes, you can. No. You cannot take that value because it's not a constant one. It is continuously changing. So you have to take a gradient, and you have to take a gradient of a linear region where the line is straight. Only gradient of this region you can take. If this graph was like this, for example, if a displacement time graph was in this manner, then you can take any distance because the starting value is 0, so any distance and time you'll get. But here you have to take a gradient because it is started with the maximum value, like it started with 20 and then it started to decrease. So how much distance it, like when we take this time interval, so from 10 centimeter, how much more it covers, so remaining 10 centimeter and the time interval as well. So you have to take a gradient for a displacement time graph. Then student heated the liquid and repeated the experiment. The ball bearing took less time. Assume that the density of a liquid is constant. So what actually happened when we increase the temperature, we reduce the viscosity. Like the liquid become less viscous. So as it become less viscous, the drag force will decrease. And as when the drag force will decrease, the terminal velocity will increase. Because you have the formula that upthrust plus viscous drag is equals to weight if it is going downward. So this value, the viscous drag is decreasing. Because the sum should be, so as a result, we need a higher terminal velocity. We have F is equals to 6 pi eta R and V. So for this constant, if the viscous drag, if the viscosity is decreasing, as we increase, how to relate? You'll mention increase in temperature, increase in temperature reduces the viscosity of the fluid. As the viscosity of the fluid will decrease, if we want a constant value for a viscous drag, so the terminal velocity should increase. Like, for example, if we need a viscous drag of 3 Newton, so if we have a less viscous medium, then the terminal velocity should be higher. If we have more viscous medium, then the terminal velocity will be lower. So F is equals to 6 pi eta R V. So how you score the 4 marks? First thing you will mention that if you want for a terminal velocity, first condition for a terminal velocity, the terminal velocity, in this case, the upthrust plus viscous drag should be equals to W. Means the sum of upthrust and viscous drag should be equals to W. So the sum should not change as we want a constant value. Upthrust cannot be changed. So now the viscous drag, we want a constant value for a viscous drag, which is 6 pi eta RV. So radius cannot be changed. And when we increase the temperature, the viscosity is decreasing. So the terminal velocity should increase to balance the change in viscosity. So that's why the ball bearing will have a higher terminal velocity. Because we want a constant value for the viscous drag. So this was a quiz which was related to fluids.